So Alex has just started Quadratics and he wanted me to give him a quick introduction. So I think that your class should be starting with Vertex Form probably. That's what my class started with, and it's pretty simple. So we'll just go over it. So down here is standard form. This is what you're used to. This is the kind that you factor and solve to find the roots. But here is vertex form, and what's good about it is that you can easily find the vertex with these variables p, q, and a. So let's take a look at this graphing calculator. Here's a graph of y equals x squared, just the default function. Now if we put a something for a q, let's see what happens to this graph. So just put plus, let's say 2. Now let's go back just a second. See, it starts at 0. This is the vertex, by the way, the lowest point on the parabola. Now if you put the plus 2 back, it goes up 2. That's what the q does. It is called a vertical displacement. Let's just put, oh my god, D for displacement. That's what the q is. Now, instead of changing the q, let's try putting something for p. So we need to put a brackets around this one, or else it won't work. And it needs to be under the exponent too. So x, let's do minus 3, then squared. So look, the original graph was at 0, and now it's at 3. So this is called a horizontal displacement. And this is a bit trickier than the vertical displacement because it has the opposite sign. Let me explain. So it's negative 3, but it moves positive 3, or it moves 3 in the positive direction. Now if you do positive 3, so plus 3, moves 3 in the negative direction. So it's always the opposite of what the sign shows. That's why in this notation we use a negative sign, not a positive sign. And now for A, this is called a vertical expansion. Let's have E for expansion. So this one doesn't actually change the vertex of the graph. All it does is change how narrow or wide the graph is. So let's try something like 2. It just got skinnier. So what happens is that if see on the normal parabola, this point right here, 1, or let's see this one, 1, 1, after you do 2, it multiplies the y value by 2. So it would then change into 1, 2. So that's what it does. But also, you should know that if you multiply it by, say, 1 divided by 2, oh wait, 1 divided by 2, it gets fat. So let's see that 1 point, 1, 1 that was this point. Now it's at 1, or this point, 1 comma 0.5. So it divides each y value by 2, and this makes it wider. And can also do 4. The higher it goes, the wider it gets. 8, and it keeps getting wider and wider. Same as if you do like 6, or let's say 10, it gets really, really skinny. So those are all the variables in the vertex form notation. What this notation is good for, as I said, was finding the vertex. So let's say we have a equation y equals, let's just put a as 1, so not put it there, x minus 5, and then plus 3. Now, what you'd be expected to do is find where the vertex of this graph is, now that you have p and q, 5 and 3. So, let's see what we said for q. So q is a vertical displacement. You have to remember that y equals x squared has a vertex at 0, 0. Now, if you have it in vertex form, and you have p and q, then the q is just do v equals, you add 3 to the y value, so 3, then 5, negative 5, you want to take the opposite of this, because in the notation it has negative sign, so negative 5 is positive 5. This would be where the vertex of this graph is. Here, let's just put it in our graphing calculator. Y equals x minus 5 squared. So let's do that. X minus 5 squared. See, already it's at positive 5, and then plus 3. So this is at 5 comma 3 text. This is what we wrote right here, 5 comma 3. Now, oh, there's one thing I forgot to mention about the a. So let's just do x squared. There's also negative sign x squared. This just flips the parabola around. So if a is negative, then it'll be pointing downwards. If a is positive, it points upwards. That's all it changes. It's just the same graph, except it's pointed downwards. So yeah, that's pretty much it about vertex form. Yeah, thank you, Alex.